So this lesson is going to be a little bit like a choose your own adventure kind of lesson, because now that we know how to do graphing, substitution, and elimination to find the point of intersection, sometimes we have a choice which one is going to be the easiest one to use for a certain equation or set of equations. So when we look at the first two equations that we have here, Mathman's back, and he's asking if we should be using elimination or substitution here. I'm seeing columns. Are you seeing columns? I think it would be much easier to do this using columns. So I'm going to draw my columns. There we go. And we have 4 columns this time because these equations are in what we call standard form. Okay. Now we're going to check for zeros. And remember, the zeros have to come from the x or the y's. They can't come from the number columns. Are there any pairs there that are going to add up to 0? Not yet, right? But what if I stuck a 3 right here? So it's negative 3y, and that would add with positive 3y to make 0, right? If I stick a 3 there, that means I'm timesing y by 3, so I need to multiply x by 3. I need to multiply negative 2 by 3, and I need to multiply 0 by 3, and that's not going to change. So let's go ahead and add all these up. 2x plus 3x, that's 5x. We already did the y's and got 0. Negative 9, so we have 9 negatives, and then 6 more negatives come along to join them. So now we have a total of 15 negatives, and 0 plus 0 is still 0. So here's our equation. 5x minus 15 equals 0. That's a lot simpler than what we started with. Let's add 15 to both sides. So we're going to make that 0. So we have 5x equals 15. Let's divide both sides by 5. We have x on the left and 3 on the right. Okay? So all we need to do now is pick one of our equations to try to figure out what y is. And again, I'm going to pick equation 1 because we didn't make any changes to it. So if I do 2 times x, it now should be 2 times 3 because we know x is 3. And then I have plus 3y minus 9 equals 0. So we have some things to move over. I have 6 plus 3y minus 9 equals 0. And if we collect up our like terms before we switch sides, 6 positives and 9 negatives, the negatives win by 3. So I really have 3y minus 3 equals 0. If I add 3 to both sides, I'm going to have 3y equals 3. And if I divide both sides by 3, I'm going to get y equals 1. There's that 1 again. Remember, I warned you. And so therefore, the point of intersection for these two lines is x equals 3, y equals 1. Remember, we do x and then y in that order always. I think on the previous slide we should have had like audio with Mathman going, "That's right." Oh well, we'll work on that. Here's our second example. And the way this one works, we could actually use either, and I think it would be just the same amount of work. What if we use substitution just to practice that and then advance for a couple of lessons? If c is equal to 40 plus 50, 40t plus 50, and c is equal to 45t plus 30, then 40t plus 50 has to be equal to 45t plus 30. So if I minus 50 from this side, I have 40t equals 45t plus 30. And if I minus 45t from this side, I also do it here. Then that's going to make 0. I have 40t minus 45t equals 30. 40 take away 45 is negative 5. Don't be afraid to use your calculators to double check on some of these. And so negative 5t equals 30. If we divide both sides by negative 5, t equals negative 6. And I could use either one of those two equations that we started with to find my c value. And so if I work over here, I can now say c equals 40 times t, which is negative 6, plus 50. Or you could use the bottom equation as well. It doesn't matter. C is negative 240 plus 50. And so negatives win by 190 here. Therefore, POI is, and when we write it as a POI, it's hard to know which is our x value and which is our y value, isn't it? I think that we're going to take the t value as our x and the c value as our y, because the way that this equation is written, c is a function of t, so we need to know t before we can figure out c. So that makes more sense for that to be our x and our y, but in this case this is our t and our c. And you could just write that, therefore t equals minus 6 and c equals minus 190. Where is Mathman when we need him? This one looks a little different, doesn't it? So here's a case where we've got the first line written in general form, y equals mx plus b, and then the second one is written in standard form or close to standard form. This is actually called intercept form. And so probably the easiest thing to do here is to look at this chunk as equal to y, and we're going to substitute that into the second equation. So we would have 6x plus 3, but instead of y, we're going to use 5x minus 2 there. Now we do the rainbows. We have to multiply the 3 into the bracket. So we have 6x plus 15x minus 6 equals 36. And we're going to add up like terms. We have 6x's and 15x's, so there's 21 x's. And now we're going to add 6 to both sides because that makes that 0, and over here it makes it 42. This is when I get excited because I know that 21 goes into 42 2 times, so it's all working out nicely. Let's divide by 21 on both sides. Cross off the 21, x equals 2. And probably the easiest thing for us to do next is to use the very first equation, y equals 5x minus 2. I know x equals 2, so that's just 5 times 2, and then minus 2, or 10 minus 2. So y equals 8, and the POI is 2, 8. I hope that these are becoming a little more simple. The more that we practice together, hopefully we're seeing the steps and really understanding what we're doing each time, and they're getting a little easier and faster for you. I'm seeing columns. Are you seeing columns? I like it when they're lined up this way. I'm going to draw some columns and my line underneath, and now I'm going to look for a column that makes 0, and I don't have one. But what if I multiplied everything in the top row by negative 2? That would give me negative 4y here, so that plus positive 4y equals 0. So I'm going to do the same here. I'm going to multiply the 5x by negative 2 and make that negative 10x. And the 18 times negative 2 and make that 36. So we're going to replace our first equation with the one I wrote in red. And now we're ready to add up the columns. 10 negatives and 2 positives. The negatives win by 8, so we have negative 8x. 4y and 4y, that's our 0. And negative 36 plus 18, the negatives win by 18 there. And so we have negative 8x equals negative 18. Oh, this one's not going to work out to a whole number. Interesting. Okay. divide by negative 8, divide by negative 8, x equals, negative and a negative make a positive, and 8 over 8 is 9 over 4, or we could write that as 2.25, probably much easier if we do it as a decimal. When it comes time to finding y, let's put that decimal in for x. And so we're going to use equation 2. I'm going to use 2x plus 4y equals 18. And x is 2.25. And then plus 4y equals 18. So this would give me 4.5 plus 4y equals 18. I'm going to minus 4.5 from each side, so that makes 0. 4y equals 13.5. Oh, I'm getting messy. My apologies. Let's write that whole line again. 4y equals 13.5. So divide by 4, divide by 4. You're going to need your calculator for this one. Y equals 3 decimal, what's that going to be now? 3, 4, and we'll round off to 2 decimal places there. So that's a strange one where our POI comes out as 2 decimal values, but it doesn't always have to be whole numbers, and so it's not wrong when that happens. The only time that that's really bad is if we're being asked to do it using graphing only, because we would have no idea exactly what the decimal would be. We can only read whole numbers from the graph, and so you definitely would have to use substitution or elimination when that happens. So practice is key in math. The more you do, the more patterns and shortcuts you kind of see, and the easier it gets for you to do these problems. So there are 10 practice problems on the worksheet. Try them all, take your time, put in every step, and then check your answers and make sure that you're doing it right. And don't forget, you can check your answers using left side, right side so that you know on a test that you're handing in the right answer.